Hey y'all, so this is your 5-minute review on redox reactions with Intro to Electrochemistry, galvanic cells, and electrolytic cells. Alright, redox reactions, oxidation and reduction. A redox reaction is a reaction where high energy electrons are transferred to low energy electrons, and then that produces energy. And there are two parts, as we all know, to redox reactions, oxidation and reduction. Oxidation is the losing of electrons, and reduction is the gaining of electrons. And there's an acronym, oil rig, that helps you remember that. So oil oxidation is losing electrons, and rig reduction is gaining electrons. Half reactions break down redox reactions into two reactions from which we can interpret and find the element in the reaction that is oxidized and the element that is reduced. And you can remember R and R, so reduction occurs at the reaction where the electrons are present in the reactants, and that's semi-easy to remember since they both start with the same letter. If you look at this example right here, we have two half reactions with zinc and hydrogen gas, and if a question was to ask you like which element oxidation and reduction occurred at, you could be able to tell by this with the electrons are in the reactants of hydrogen gas, so therefore hydrogen gas would be where reduction occurred, and zinc would be where oxidation occurred. Another method for determining where oxidation and reduction occurs is by looking at the cell potential. And here in this diagram you can see a lot of the cell potentials from half reactions. And the highest cell potential would be where reduction occurred, and the lowest would be where oxidation occurred, and you can see that in the upper right hand corner in the diagram. Oxidation numbers are also used to determine which element reduction and oxidation occurs at, and the oxidation number is the number of electrons an atom gains or loses, and then the rules for assigning them are free elements are always 0, and then for ions you look at the charge. Oxygen is -2, peroxides are -1, and hydrogen is +1 with nonmetals and -1 with metals. And then in neutral compounds, the oxidation number will add up to 0, and for ions, the oxidation number will add up to the charge of the ion. So here's some practice with assigning oxidation numbers. For this oxygen always has a charge of -2, so then manganese would have to have a charge of +2, and then chlorine has a charge of -1, hydrogen has a charge of +1, adds up to 0. And then for the products, for this chlorine, chlorine has a charge of -1, and there's 2, so manganese would have to have +2 to equal 0. And then here oxygen always has -2, and then hydrogen has +1, but there's 2, so that would equal to 0 as well. And then chlorine is a free element here, so it would have a charge of 0. So chlorine would be the element oxidized as it lost an electron from the reactants to the products, and then there would be no element reduced because no element gained electrons. So balancing redox reactions, I won't go over the steps now because I'm running out of time, but they're very similar in acidic and basic solutions. The only difference is there's one extra step for basic solutions that neutralizes the reaction. Right, so galvanic cells generate current, and an anode is the electrode where oxidation occurs, and then a cathode is the electrode where reduction occurs, and you can remember that from anox and redcat. So here in this example, you have a copper anode and a silver cathode, and since anode is where the oxidation occurs, the electrons will flow through the wire to the cathode. So the copper metal at the anode is moving off into the solution as an ion, which makes the electrode lose mass, and then it forms a V shape at the bottom of the anode. And then the silver electrode gains mass as the copper ions in solution combine with the electrons that came from the anode. And then the salt bridge here acts to balance the charge of ions to help with preventing charge buildup. And then the voltmeter measures cell potential. So electrolytic cells require current, and it's everything opposite of the galvanic cells. So it converts electric energy to chemical energy instead of the galvanic cells converting chemical to electric. And then the current runs opposite of a galvanic cell and is supplied by outside source. So in an electrolytic cell, the cathode and the anode are in the same container with no salt bridge, but a porous barrier in between, so like a filter paper, separating them in solution. Electrolytic cells need an outside source, which would be the battery here, in the galvanic cell. In it, running it, and then the cathode of the galvanic cell would be right here, and it would be giving electrons to its anode, and then in turn that would give electrons to the cathode of the electrolytic cell. And this is from coupled reactions. So in this example, we're trying to find M and M2+. And if we look at the electrode here, the electrons are leaving, which means it's oxidation. And the electrons for the zinc would be in the products, which means that would be the oxidation. And then that would leave nickel to be the cathode.